Hello and welcome in today's video about Cisco 300-430 exam review. Today we're going to talk about implementing Cisco Enterprise Wireless Networks. And in today's agenda, we're going to talk about QoS, or quality of service over Wi-Fi. And we're also going to talk about voice over wireless. We're going to talk about multicast and the difference between multicast and unicast. And also the difference in AP modes such as Flex Connect and local mode and monitor mode. But before that, I'm going to talk about 591 Lab. It is the top IT training and certification exam brand in China, Hong Kong, Taiwan, and Singapore. Our mission at 591 Lab is to provide our clients with exceptional exam preparation experience for certifications in Cisco, Huawei, Aruba, Juniper, Palo Alto, and Fortinet exam tracks. So let's start with our first question. An engineer configures the QoS, or quality of service, on an ENWLSI version 8.5. The engineer configures a wireless LAN for voice traffic and must give a higher priority to WMM clients than to non-WMM clients. Which two configurations should be performed? Now, about WMM traffic, it's short for Wi-Fi multimedia. It is basically used to prioritize different types of traffic such as voice, videos, or calls, used basically for media. So what this engineer wants to do is he wants to give the Wi-Fi multimedia clients, the clients that basically uses media such as phone calls, videos, streaming, or whatever. He wants to give them higher priority than the non-WMM clients. Those are clients that do not use media in their traffic, such as like regular traffic, website browsing, or emails. So what can we do actually to do this, to give the WMM clients more priority than the non-WMM traffic? Let's see the options that we have. Should we implement the Platinum QoS service or profile? So should we set the multicast default priority to voice, select video from unicast default priority drop-down menu, implement the Gold QoS profile, or set unicast default priority to Platinum? So the difference basically between multicast and unicast is in unicast, I'm going to send from client A to client B as a unicast message. It's not going to be propagated, it's not going to multiply on the network or anything. It's just going to be from one to one. But multicast, if we are going to send the same data or video or a phone call or whatever it is to multiple devices, instead of the client have to send them multiple times and duplicating them to, let's say, 10 clients, it's gonna be very overhead on the client and on the network if I'm gonna duplicate the traffic 10 times. So what multicast mean is I'm gonna just send the traffic or the data one time, and it's gonna be duplicated automatically to these clients or to all the clients that in the multicast group. So I don't have to send them multiple times to multiple clients. And it's very helpful when we talk about voice or video, or in our case, multimedia traffic. So because if I have to send the same data multiple times to multiple clients, I'm going to take a lot of traffic. I'm going to take a lot of utilizing the whole network. Okay. So what can we do in this traffic? So if we open the wireless LAN configuration, for example, voice SSID, we're going to see a QoS settings, and in this I'm going to see quality of service. Here also we can see the WMM policy, and we can see that it's allowed. Okay, it's allowing the WMM clients. Okay, and in the quality of service I have the option actually to change the priority of the traffic. So it depends on the SSID I'm gonna use. I do not put the higher priority to all SSIDs, and I do not put the lowest priority on all SSIDs. So in this voice SSID, I'm gonna actually put Platinum, which is the highest, and it's set for voice. Other services, it's Gold for video streaming network. So because it takes less than voice, the voice is the most important, because if we get any delay in voice, the voice is gonna sound cracky. It's gonna sound not very clear. So for video, it's gonna be, sorry, for voice, it's gonna be platinum. For video, it's gonna be gold. And for all the default profile, it's silver, which is for general network data or anything else. And the bronze, we set it, the lowest one, the bronze, we set it for all guest networks, basically the lowest priority. So let's get back to the question. If we're gonna put the multicast default priority to voice, this is not a good option, because we do not want to set the multicast default generally to all SSIDs. So it's not a good option, because we only want to put it on the wireless LAN that's for voice traffic only. And if we're going to select video, we're not talking about video here for the unicast default priority, we're talking about voice. So this option is not good as well. And also, we talked about the gold QoS profile. The gold is also for the video, and in our case, it's not what we want. So we do not want this option as well. The best options to choose is to implement the platinum QoS profiles, just like we saw in the previous picture. So the platinum is used for the voice traffic, and also we set the unicast default priority to platinum. So we set the highest priority to the voice calls. Okay, so the answer is going to be A and E. Next one. An engineer set up a local authenticated Cisco Flex Connect AP with a guest LAN. Guests report not being able to authenticate. Which configuration must be changed on the wireless LAN for guests to be able to authenticate? Is it AAA override, radius NAC, backup radius server, or central authentication? But before we proceed with the answer, I need to understand something. We are using local authentication, basically the Flex Connect access point. It uses local authentication. It's authenticating the guest clients on its own, rather than going to an actual ICE server or a radius server and using it for the guest LAN. So I need to understand, is this even allowable? Can the Flex Connect access point with a local authentication, local traffic can be authenticate on its own? And if we check the website for Cisco website for Flex Connect data sheet, we're going to find this basically, that guest authentication cannot be done on a Flex Connect local authentication enabled wireless LAN. Okay, so we can use the guest wireless LAN on a Flex Connect AP, but certainly we cannot have the wireless LAN set as a local authentication enabled. This option is not available for guest authentication, yet it can be used in a .1x SSID or a WPA, simply a WPA SSID, but not a guest authentication, because the guest authentication needs a lot of computing, a lot of authentication to do. So this can be done with a radius server. So basically, we need to change the local authentication to central authentication. So the change that I need to done, the configuration need to be changed, is the central authentication on the wireless LAN itself. Just simply change it from local authentication to central authentication. Question number 3. During discovery, one out of five fabric-enabled wireless LAN controllers is not being properly discovered. The firewall rules are the same for all the controllers. Which element is missing? Netconf, Yang, SNMP management, or SNMP trap. So if we go to the controller, in our case here, it's a Catalyst controller, we can see the SNMP mode, and we're going to see the community string. If this community string or community name is not correct, let's say that on the controller we put a different name than the DNA, the controller is not going to be able to join the fabric. So this is one option that we consider. SNMP is not correct. And another option that we must see is this page is taken from a DNA discovery page. So we can see the IP address is correct, the SNMP, and we have two options that we talked about. The SNMP, again, we need to make sure that the community string or the SNMP management string is correct. And also we have the netconf. Especially in the Catalyst controllers, not the AROS, we have the netconf option, because if we have it disabled or the port is not correct, the controller is not going to be able to be discovered. So from this question, I can eliminate any other option and focus on net configuration or an SNMP management. But in this question, it requires us to have one answer only. So if we're going to talk about a Catalyst controller, I'm going to have the options of netconf and also SNMP management. Okay, these two options are actually correct, both of them, if we're going to talk about a Catalyst controller, because we need to check those two if they are enabled, if they have the SNMP management community string. But if we're gonna talk about an AROS controller, an AROS controller does not need netconf. It only works with SNMP management. So since this question only say about only allows to one option only, I'm gonna keep my answer to only SNMP management, because it can also work on both AROS controllers and Catalyst controller. So if we're talking about an AROS controller, then the answer is C. If we're talking about the Catalyst controller, or if we have two options to answer in this question, then the answer should be netconf and SNMP management. Okay. Next one, which Cisco Prime infrastructure report does an engineer run to troubleshoot client connectivity issues for a VoE Wi-Fi network? A VoE Wi-Fi network is a voice Wi-Fi network. Okay, so which report does Cisco's Prime infrastructure need to be run in order to troubleshoot the client connectivity? Is it AFS or airtime fairness statistics, .1 counters, traffic stream metrics, or up-down statistics? So if we're going to talk about up and down statistics, basically this is going to mention the speeds of the up and down of the upload and download. It's going to mention how many gigabytes have we downloaded and uploaded. So it's not going to be very helpful in our voice Wi-Fi troubleshooting. Okay. If we're going to talk about airtime fairness, it's not also helpful, because it's not going to point to the issue that the voice Wi-Fi network have. And also .11 counters, it basically says like how many clients are connected, how many disconnected, and so on. So it's not also helpful. But traffic stream metrics, or as we call it TSM, it's generated for the selected access point, and basically show us QoS statistics, latency of the voice traffic stream. Okay, so this is very helpful when it comes to voice network, because it will show us the QoS status. So if we see in the TSM report that, for example, the QoS is not correct, we can have an idea why we have the issue. So this is the most helpful option that we have, traffic stream metrics. So the answer is C. The marketing department in a retail company has created a promotional video for the opening of a new branch store. Okay, so this is the video name for the branch store that they need. For the video must be received by all interested hosts only over wireless multicast. What allows this feature? So basically they have a video, and we see it a lot of in marketing in a lot of malls and retail shops, that they have one single video and it's broadcasted all the way to every single TV that they have in the store. So like we said, instead of sending the video by using unicast one by one to every TV, we use multicast to send them to all interested parties or interested hosts only. So which one allows this feature? Is it TPC, WMM, WMF, and DCA? So let's basically eliminate these two right here, because TPC, as we know it, is transmit power control. It has to do with the power of the access points of the signal power for the access points. So definitely this is not this has to do nothing to do with the multicast. And also DCA is dynamic channel assignment. It has to do nothing with multicast. It has to do with the channels or selecting the channels for every access point. So it's not really good option. But if we talked about Wi-Fi multimedia, okay, this is actually helpful. But if we're gonna talk about the video received by interested hosts only, we are for the main option that it's gonna be helpful for us is WMF, or wireless multicast forwarding. It's basically an efficient way to forward the traffic on the wireless network. Okay, it transmits traffic only to the targeted member of the multicast group. Okay, so it uses Internet Group Management Protocol, or what's called IGMP, to keep track of the participants of the group. So it uses only the interested hosts only, not all groups, just like the WMM. It uses only the entities or the clients in that specific group. So the answer in this case is going to be WMF, or multicast forwarding, wireless multicast forwarding. Number 6. An engineer configures Cisco CMX, which uses layer 2 high availability on primary and secondary CMX instances. So we have high availability, but on CMX, okay, so we have two devices, two CMXs, secondary and primary and secondary. According to the specification, we have the primary set as this 192.168.1.4/24 subnet, and the secondary is set to the same but .4.4, so it's on a different subnet. Keep this in mind. And the virtual IP address for them is .4.1. okay. During testing, the engineer discovers that the failover fails. They're not able to fail over to each other. Okay, which actions resolve the issue? So the main information we need is basically here. They gave us the IP address, but let's take a second to review what are the prerequisites for high availability for CMX, or what configuration need to be done on the CMX in order for the failover to happen. Okay, we can see that for both the primary and secondary server should be on the same size. The devices need to be on the same size and the same type. So we cannot have a different VM specifications or different physical appliance. They need to be the same, the exact same size and the exact same type. Okay, but in this question, it did not say anything about this. Okay. Both the primary and the secondary server should have the same Cisco CMX version. Okay, but also in this question, it did not mention anything about the CMX version. Okay, both the primary and the secondary server should be connected on the same subnet. So both should be on the same subnet IP addresses. So we'll check. If we check this, we can see that the primary controller, the primary CMX address is on .1.4 and the secondary is .4.4. So we are not on the same subnet. We should be on, for example, .4.1, and the second should be .4.4. Okay, so we should be on the same subnet to be able to have the failover happening. So it could be this one. Both the primary and the secondary server should be connected on the same subnet if layer 2 HA is required. So again, the same point. Both of them should be connected on the same subnet if layer 2 is required. And in our case, we are actually using layer 2 high availability. So this again on the same thing, both should be on the same subnet. Both the primary and secondary server should be IP connected with delay less than 250 milliseconds if layer HA is used. Here we did not mention anything about delay or layer 3. So we're gonna stick with the main thing. both secondary server and primary and secondary server should be connected to the same subnet. So the answer should be A, place the primary and the secondary in the same subnet. Like we said, we put them on the same subnet and the failover should happen. Okay. Next one. Refer to the exhibit. An engineer must identify jammer devices on the wireless network. The access point must scan all configured channels. Which AP mode must be configured to accomplish this? Okay, so let's see the picture. Okay, so here we have, in this tab, basically on the controller, we go to the interference devices. We can see that this access point on this radio slot 0 or 2.5, it's getting affected on all channels, all the way from 1 all the way to 11 on all channels at this time, and the severity of this one and our SSI is actually very high, so we expect it to be highly affected on every single channel. Okay, based on this information, which AP mode is suitable for detecting and containing this jammer device, okay, to accomplish this? So the default mode of an access point, if we're talking about client serving, it's going to be either local, so the local is locally transmitted or locally switched, or flex connect. In these both modes, actually the access points do the what we call off-channel scanning. It goes off-channel. Like, let's say that the access point is serving clients at channel 1, it will actually go to the other client or other channels to do an off-channel scanning for any ROG devices or ROG access points. Okay, but it's definitely gonna be on and off. It's not gonna be helpful, especially when we are being affected on all channels. Okay. So this will only go off channel scanning for milliseconds and then go back to serve other clients. So if we want an access point to be scanning all channels at the same time, or like small sequence between them, we're gonna go with the monitor mode. Monitor mode, basically, it does not service any clients. Like it says, like the name suggests, it's only gonna be monitoring the wireless or the Wi-Fi spectrum. So the answer is B. A wireless network has two RF groups where Cisco WLCs are joined. Okay, APs are associated with different controllers using the round-robin approach. Okay, so we have two RF groups where the Cisco WLCs are joined. We have multiple WLCs, and the APs are associated with different controllers using round robin, basically, which means an AP can go to the first one, the second AP go to the second one, a third AP can go back to the first one, and so on. Rogue containment must be deployed on all controllers, but the network must not be affected by any RRM neighbor packets sent by friendly APs. Which AP authentication and protection type must be enabled? So basically, since we have multiple controllers, we do not want the rogue containment to be happening on a friendly AP. We want it to be something not happening on the wire side. Okay, because all these access points are on our network. So are we gonna use AP access control? No, because this is basically, it's not helpful in this situation. We're talking about RRM neighboring. We're not talking about anything like security. Also, security and authentication is not helpful. We're talking about to be affected if we're gonna talk about rogue. If we have any security issue over the Wi-Fi, we're definitely gonna use the AP wireless protection rules. If we have these friendly access points on our network, on our switches, basically I'm gonna go to the AP wireless protection rules on the controller, and I'm gonna put that if any AP is using our SSID, or it's connected on our switches, on our physical switches, on our physical wired network, please consider them as friendly access points and do not contain them. Okay, so this is the best thing to use. The security, the authentication is basically a way to authenticate the access points whenever they want to connect to our controllers. It could help if we want to eliminate anyone like connecting their access points to our network, but in our question, if we're going to talk about two RF groups, and we're talking about RRM, and if we're going to talk about radio management or raw containment, we're going to talk about the AP wireless protection rules to say, like, if the access point is using this specific SSID and it's connected on our wired network, please consider them as friendly access points and do not contain them, do not do anything against them. So the answer here is B, what AP wireless protection rules. So that's it for now. Thank you all for attending today's class at 591 Lab. We hope you found that material informative and helpful. And remember, practice is critical to mastering any new skill. So review the course content and keep practicing with 591 Lab help and support. If you have any questions or concerns, please do not hesitate to contact us. We appreciate your participation and look forward to seeing you all in our future classes. And have a great day.